Want to get started with this because I'm a little bit worried about time. Some of the later stuff takes a little bit longer. All right, the purpose of this is we take what a determinant does. First of all, there's two ways we show determinant. This way, or by using an absolute value sign. Those are the two symbols for determinant. What determinant does is it takes a matrix and it turns it into a number. Now, you can only do this with square matrices. So you can't take a determinant of like a 2 by 3 or a 3 by 1 or anything else like that. Only works with 2 by 2s, 3 by 3s, 10 by 10s. I guess you could do a 1 by 1, but it's just that number. Okay, with a 2 by 2 is kind of a special case. We could go through the big long rule, but a 2 by 2 is, there's just a quick simple rule for a 2 by 2. What you do is you cross multiply and subtract. So what I do is I take A times D minus B times C. So I cross multiply and subtract them. That's all you have to do to find a determinant. So if I try to find the determinant of these, a lot of times when we get used to this, you can find determinants of 2 by 2s quickly in your head. But I'm going to do this, write these out. So I take 5 times 3 minus, and I go in the other direction, 2 times negative 1. So that's 15 plus 2. If you do the next one, same exact thing. 6 times 2 minus negative 4 times negative 3. So that one will be 0. Okay, that's all there is to determine it for a 2 by 2. All right, you okay with that? Questions, concerns? Do I need to stay there? All right. Okay, so the normal process, and this works with any kind of matrix, well, any kind of square matrix. What you do is you take elements along the top. So if I take an element here, I ignore the rest of the things along that row and that column. I take that item times the determinant of whatever's left inside of here. I'm trying to think of a good way of representing that. Whatever's left over inside of there. No, I'm not meaning to be 0. That's going to be a number in here. I just meant to circle that, whatever that is. Okay, then you subtract the next thing. So then I move over a space. So say the next thing here is y. So I circle that one. I ignore everything along the row and the column. Everything else here, so I would take this and this, and I would take y times the determinant of all of that. Then I would move over to the next item. Yep. And I ignored the row and the column. And I would take whatever's over here and over here. Now, what you do is you keep alternating signs. So the next sign would be plus. And you keep going until you have finished that top row. You don't have to do any more rows. You just go across the top row. So if the top row has 3 things, you do that 3 times.
So for the thing of 4, then we have to do a new thing of like this?
Yep, I'm going to show you. I'll do an example like that. All right, so if I'm going to do, let's do the 3. So example 3. I'm going to start with the 3 here. So I'm going to take 3 times the determinant of, okay, so I ignore this row and this column. So what's left over? Yeah, sorry. So I use the 3. So I ignore this row and this column. So then what's left over is that. So I'm going to take that 3 times the determinant of 0, -2, -3, and 5. Okay, then I move over to the next number. Okay, I put a minus sign in here. So -2 times the determinant. Okay, I ignore the top row and the column that had the 2 in it. I write down those numbers that are left over. So that'd be 4, 1, -2, 5. Okay, then I have a plus, and I do the next number, so it's -1. Times, okay, ignore that column, so I'm going to use those numbers this time. So 4, 0, 1, -3. Okay, so then this one, I do this determinant, so that's, if I do this cross multiplication, so it's 0 times 5 minus -3 times -2. Now see, this would be one of those places where it helped to do it really quickly in your head. Okay. Oh, wait. Yeah, she's here.
And then for all this special labs and stuff, do we print it out or email it to you?
Either way. And if you print it out, or if you email it to me, I'll print it out. So either way. Okay, minus 2 times, I do the determinant of that, so that's 4 times 5 minus 1 times negative 2. Okay, plus negative 1, so that's the same thing as minus 1 times 4 times negative 3 minus 1 times 0. So it equals 3 times negative 6. Minus 2 times, let's see, it's 20 plus 2, so it's 22. Minus 1 times negative 12. So that ends up being negative 6, negative, and negative 44, so negative 50. Okay, I'm not going to do the full thing, but I want to show you real quick what this looks like with even a bigger matrix. Because it would take way too long to do the full thing. Am I okay to move this? Okay, so again, we're not going to do the full thing. I am not going to ask you to do one this big, but just so you see the concept, I want to start doing this one. So what this one would look like is, where you start it, it would look like 5 times the determinant of 3, negative 1, 4, 1, 1, 3, 2, negative 1, 2, minus negative 1 times the determinant of 1, 2, negative 5, negative 1, 1, negative 1, 4, 3, 2, plus 0 times the determinant of 1, 3, 2, 1, negative 5, 2, 3, 2, minus 2. So each time you go, you keep alternating signs. Plus, minus, plus, minus. 1, 2, negative 5, 3, 1, 2. I am bound and determined to make this fit. Okay, so that's the first step. Then you'd have to go through and do the determinant of each of those 3x3s.
Can you eliminate the third one?
Yeah, the third one would disappear because it's times 0. But you then would go through, and this one would look like 5 times 3 times the determinant of 3, negative 1, 2, minus negative 1 times 1, 2, 3, 2, plus 4 times 1, 2, 1, negative 1. Then you'd have plus 1 times, and it would keep going. Again, I'm not going to do the whole thing. We could. This is why this is so good for computers, because again, it breaks it down. It's the same steps over and over and over again. You put this in a loop in a computer, and a computer can handle it. It can handle doing it quickly. But I want you to realize that, and hopefully you get kind of the concept. It's just repetition of the steps.
So on the test, we're gonna do this by hand, but like how big is it?
No bigger than a 3x3. No, I wouldn't. I'm not going to expect you to do anything like this.
Just the
Yeah. Okay, now, with the 3x3, there is an alternate method. So let me show you the alternate method for a 3x3. And if you've had matrices, I don't like this method, but I know that there's a lot of teachers in this building who prefer this other method. So most likely if you've had matrices before, you've been shown this other method. So I don't care which method you use. It's not going to hurt my feelings if you use this method over my method. Which isn't my method, it's someone else's method. Okay, what you do is you take the first two columns and you copy them down again. Oops, that's supposed to be an H, not a B. Okay, then when we do this, we're going to make two things. We're going to multiply in this direction. We're going to take A times E times I plus, do this multiplication, plus, so any diagonal where you can multiply together three things. And then we're going to subtract off the multiplications in the opposite direction. So it's kind of like you're cross multiplying again. So now we go backwards. Anything going diagonally down that direction goes in the first one, and then you subtract off anything going diagonally down in that direction, where you can put three of them together.
Yeah, I forgot the outside things.
So let me do an example like that. Again, I don't care which method you use, so if you find this method easier, use this method. I prefer the other one simply because it can be used in bigger things, and in college that benefited me more than the other method. For what you guys are doing, either method would work for you, because I'm not going to ask you to do anything bigger than a 3x3. So honestly and truly, pick whichever one you like more and you feel more comfortable with. So with doing this one, if you would write down 3, 2, -4, -1, 3, 1, 2, 5, -2, and then on the outside you copy down the first two columns. So 3, 2, -1, 3, 2, and 5 again. Okay, then you do, starting with the first number, you do multiplications down in this direction. So 3 times 3 times negative 2. Let me go ahead and write it out. Plus 2 times 1 times negative 2. Or sorry, that's still positive 2. I think I said negative 2. Plus negative 4 times negative 1 times 5. Then in the other direction, you subtract those off. So you start back here at this back number, and you go in the other direction. So I'm going to subtract 2 times, I don't know why I did an arrow instead of subtraction sign, minus 2 times negative 1 times negative 2 minus,
Wait,
yeah,
so you're subtracting that whole quantity from it?
yeah, you can subtract the whole quantity, adding them together, or you can subtract them individually. It doesn't matter. It's the same either way. It's like distributing this negative sign. So you can add up all the backwards ones and then subtract the whole quantity, or you can just subtract each one individually. So let's see, 9 times negative 2 is negative 18, plus 4, let's see, that's 20. Let's see, minus 4, minus 15. See, that's going to end up being plus 24. So then my answer is, let's see, these two cancel out. Let's see, that becomes 2. That becomes 9. So 2 and 9 make 11. So it's whether you want to do it with creating the little determinants and doing your cross multiplying, or whether you want to copy down the rows and do the diagonals.